Look at this. I'm going to show you something that, in theory, shouldn't even exist. This is a live map of ship traffic worldwide. The North Pacific is completely jammed. Same with Asia, the Americas, Europe. All of this is thousands of ships hauling cargo somewhere. Now drop your eyes just a little lower to the South Pacific. And here we see nobody. Okay, if you really zoom in, you can spot a ship or two, like this one or that one. But compared to the insane traffic up north, it's basically nothing. A coincidence. And that's weird. And in a second, you'll see just how weird. Let's say South America wants to trade with Australia or New Zealand. It loads up ships with cargo and, logically, should send them along the shortest route, straight across. No need to invent anything, just load up and sail. But in reality, not a single ship takes that route. Hey, where's the cargo? Because the wind down there is extremely strong. And wind over open ocean means what? Waves. Massive Okay, hold on. I got a question. Have you seen modern ships? They're steel giants packed with technology built to survive basically any weather. Turns out it's not nearly as simple as it looks. You know what doesn't add up? Ships avoid this place because of the seas, even though the ocean has been this way for ages. If the conditions haven't changed for centuries, then sailors didn't start steering around it recently. They must have been avoiding it long ago. And it looks like they were. In the 17th to 18th centuries, mariners wrote that this was a place of endless storms, where no laws apply. And if some ancient Greeks ended up there, you know who's to blame, right? Obviously, Poseidon. Except the truth is, the rules work just fine out there. To begin with, in the belt between 40 degrees and 50 degrees south latitude, the sea almost never calms down. No true lulls, just constant motion. If the region is permanently on edge, something must be continuously feeding the wind and driving the water. Here's the catch. The winds can circle the entire planet without slowing down because there are no continents or mountain ranges in the way. So what does that do to the ocean? Total chaos can last for weeks, even when it isn't officially a storm yet. If the wind stays strong without a storm system, then the zone itself is built to keep accelerating the flow and never let it settle. Along this band, winds typically run about 34 to 56 miles per hour, and in storms, they easily climb past 67 miles per hour, and that can go on for weeks. So why is the scariest part not the wind itself, but what it does to the water? When the wind doesn't let up, the ocean turns into a conveyor belt. Old waves don't have time to die before new ones hit. The Southern Ocean becomes a wave factory. An unhinged wind drives swells for hundreds or even thousands of miles, and the surface keeps producing fresh crests. How big are these waves? If the factory runs all winter, the average sea state has to stay high. In the roughest winter zones, average wave height exceeds 16 feet. And individual crests can rise past 33 feet. But humanity's pretty advanced. Shouldn't we be able to handle waves like that? And what's the problem here? The problem is that the wave height is only half the trouble. The real danger is that they never stop. The ship survives one and thinks, okay, we're in the clear. Then a second one slams it. After it deals with the second one, a third one arrives, followed by the fourth, and then the fifth. The sea pummels the poor vessel non-stop. Captain, it's dangerous out there. Yeah, just a minute. The waves will die down. Captain? Yeah, they're basically gone. Now the question is, what happens if, in the middle of that non-stop rolling, there's an emergency on board, an injury, or a severe illness? If someone urgently needs a hospital, there has to be a fast evacuation route. But out here, there's no hospital and no land, just thousands of miles of water. So why can't rescuers simply fly in or come alongside and take the person? Because when the sea goes out of control, getting to the ship stops being hard and becomes physically impossible. The ocean loses its mind. You can't safely fly to it, and you can't safely approach it by boat. So what's left for the crew to do? If evacuation isn't possible, every problem becomes survive on site. No alternatives. No rescue. Deal with it yourselves. Goodbye. It feels like this isn't part of the world ocean at all. It's deep space where nobody's coming to help you. Oh, and speaking of space, that causes this zone a whole bunch of problems too. Above Earth, satellites and space stations circle in orbit, and every one of them has an expiration date. So what happens to all that hardware when its time is up? You can't just leave a dead object flying around forever, so when it's no longer needed, they deliberately deorbit it and dispose of it in a controlled way. They send it into the atmosphere, most of it burns up, and whatever survives falls back down to Earth. So why not let the remains land wherever they land? Because if fragments can reach the surface, you want an area where the risk to people and infrastructure is as close to zero as possible. That's why they aim for the ocean, specifically a stretch with no cities, no ports, and minimal shipping traffic. If there's a safe dumping zone, where exactly is it? Countries do this regularly, so it makes sense to have one well-known target that's easiest to aim at during a re-entry. And guess where it is? Yep, the emptiest spot in the entire ocean. Point Nemo.
Hey, what the hell is wrong with you people?
This place is so far away from civilization that even the nearest land barely counts as near. The closest little uninhabited islands are roughly 1,670 miles away. And if we're talking about actual civilization, then it's Easter Island, more than 1,860 miles from the point. So basically, the closest people to Point Nemo are astronauts. No joke, that's literally true. The ISS is only about 250 miles overhead. You know what's down there? A graveyard. Roughly 2.5 miles beneath the surface lie the wrecked remains of hundreds of different spacecraft. Okay, what was that just now? What was that, huh? So yeah, this place is basically perfect. So what we have here is a patch of ocean that's almost completely empty, and it's stormy all the time. Sounds like nothing could go wrong if a ship wandered in, right? Well, pretty much everything could go wrong. September 2002, a small yacht is sailing to Australia after a regatta. Nothing seems out of the ordinary, and then the keel breaks. For context, that's the heaviest part underwater, the thing that stabilizes the yacht so it doesn't roll over. The yacht barely has time to think, before it flips. The people on board end up in the water. Actually, it's even worse. They end up in the open ocean. In a storm, the nearest port is dozens of miles away, and that's in good weather. Now imagine what it feels like when the sea is raging. Helicopters rush to help. Well, rush isn't the right word here. They want to take off, but they can't because of the weather. And of course, there are no ships nearby. Almost none ever pass through this area. In the end, 4 people died. 2 survived by sheer luck and were rescued. Okay, so we've more or less covered the dangers, but that still doesn't fully explain why a whole stretch of ocean is so empty. There's one more reason. Sailing here is just too expensive. Yeah, even if this area looks like a straight shot, let me explain. To get a clear sense of how this whole system works, let's take another look at the map of sea routes. What do you notice? I see an insane imbalance. Seriously.
Hey, you stepped on my anchor.
Most of the traffic is clustered around just a handful of corridors. In Asia, the Americas, and Europe, even though time-wise some alternative routes could actually be shorter. So why do ships stubbornly stick to the same lanes? Here's how modern shipping really works. First, a vessel waits for cargo in port, then it loads up and sails. But not straight to its final destination, but to a massive hub port. And it doesn't arrive alone. Tons of ships converge there, all unloading their containers in the same place. From there, other vessels pick up the cargo and carry it onward to smaller ports around the world because it's cheaper that way. The schedules are predictable, the routes are standardized, and fuel use is lower. Smaller ships don't need nearly as much. Plus, you can deliver cargo even to small ports that huge vessels physically can't enter. And yes, that's all fascinating. But why hasn't the South Pacific ever slotted into this system? I mean, here's a ship carrying cargo, and around it there's literally nothing. Nowhere to drop the load, no hub ports, no intermediate stops. And without those, modern maritime trade basically doesn't function. But there's an obvious question: if a ship did sail straight from South America to Australia, how fast would it get there? Let's use a real-world route, this one from South Korea to the USA. It's not South America, but at least we've got solid numbers, roughly a 12-day journey. That's up north though. Down south, the distance between continents is so vast you can't even see both of them on a globe at the same time. Now imagine our ship sailing east from Australia. Far, even farther. Yep, there it is. Feel the difference? It's about 3 times farther. And if you factor in how crazy the ocean gets out there, our ship is going to have a very rough time. So no quick shortcut. Besides, we need a stable route, and stable is basically the opposite of the South Pacific. Hang on, some ships sail for ages without ever docking, and they're fine. I mean, it's hard, sure, but it's not exactly a problem. Something doesn't add up. Although this route is really close to the equator, and the equator is the widest part of the planet. The distances here are huge, even in a straight line. But if there's a long way around, there has to be a shorter one, right? Of course, just drop farther south, toward the pole, and suddenly everything gets closer. Yeah, except you slam into an iceberg. How do you even travel through a place where massive icebergs keep breaking off and drifting out into the ocean? To give you a sense of scale, we're talking about a slab of ice roughly 270 square miles. Running into something like that wouldn't be a Titanic repeat. Back then, the ship hit an iceberg. Here, it's more like the iceberg would wipe the ship out and barely even notice. Sure, not every iceberg is that huge, but they calve off constantly and wander back and forth across the ocean. You know what really kills the whole trade route idea? The narrower that stretch of ocean is, the higher the odds a ship will need an icebreaker escort. You've got to cut a channel and escort it, so the route needs extra servicing, and that turns into ongoing costs. But what about those couple of ships we saw right there? My first thought, fishermen. If those are fishermen, then why are there so few of them? The ocean's huge. The waters are international. There's nothing stopping you from fishing non-stop. Just look at the North Pacific. It's basically a seafood factory. The Central Pacific is busy too, harvesting tuna. But down south, the fishing scene never really took off. Why? Here's the simple version of how the ocean works. Where there's lots of fish, the ocean feeds the place itself from below. It pulls up cold water loaded with nutrients from the depths and brings it to the surface. It fertilizes the plankton, so to say, and then fish eat the plankton, and so on up the food chain. But in the South Pacific, the water just can't be bothered with that nonsense. Like I got nothing better to do. The ocean barely brings deep water up. It doesn't mix with the warm water on top, and as a result, the surface stays warm, clear, and almost empty.
I like my peace and quiet.
So yeah, this is basically a gigantic desert that mostly serves as a graveyard for space junk. There's not much to do here. But if there's nothing to do, then what are those ships we saw on the map? Who in their right mind would sail into that? The thing is, it's surprisingly hard to figure it out. I mean, finding any real information. Take the same map. When you click a ship, it shows details, vessel name, route, all that. But if you click a ship in this part of the ocean, the site gives you nothing. I couldn't learn a thing. Judging by the color of the arrows, they're cargo ships. But why they decided to take the risk and go out there is a mystery. These aren't even military or research vessels, which do occasionally come through. But what if I told you there's a place that's way more dangerous and ships still sail through it all the time? Guess what I'm talking about? Nope, not the Bermuda Triangle. Why am I always the bad guy? This is the Drake Passage. It looks like a normal gap between two continents, but don't let it fool you. Over the last few centuries, about 800 ships have vanished here, and that's only the cases we have records for. Figuring out how many actually went down will be, let's just say, not easy. I'll show you why. Remember that belt between 40 degrees and 50 degrees south latitude? Well, in the Drake Passage, this belt goes into overdrive. Average winds in this area often sit around 35 to 45 miles per hour, and that's just the normal background, not even a storm. But when a real blow hits, gusts jump to 56 to 67 miles per hour, and that's still not the whole story. Where there's wind, there are waves. Any unlucky ship entering the passage gets bullied immediately. When things are relatively calm, waves reach 10 to 16 feet, and that's considered manageable. In storms, they get huge, 26 to 33 feet, sometimes even 39 to 49 feet.
Hey, you came into the wrong street, punk.
Okay, what exactly makes this place one where everything turns against a ship? If it's not just bad weather, then there has to be one mechanism that explains the jagged seas, the freezing water, and the icebergs all at once. Some underlying cause that ties the whole nightmare together. And it's right there, Antarctica. It shapes the Drake Passage, which is why short, steep waves slam in one after another. The water is ice cold. If you go overboard, you'll lose strength within minutes. And on top of that, you've got icebergs, fog, insane winds, and serious problems with charts and communication. Oh crap, oh crap. Back in the old days, sinking here was easier than me finishing a cup of coffee before the intro. But what about today? Ships are tougher now. Look, about 15,000 ships pass through here every year, so you'd think everything should work perfectly. Modern tech, no navigate by gut feeling, and you can always call rescuers if something goes wrong. Plus, these aren't wooden sailboats anymore. Today's vessels are advanced ships made of metal, composites, and other durable materials. But you don't seriously think the Drake Passage is just going to give up, do you? For example, in March 2001, it unleashed its fury on a small liner, the National Geographic Endeavour. It slammed the ship with a wave about 100 feet high. The passage blew out the bridge windows and knocked out navigation and communications. In the end, they had to wait for a tugboat, which pulled the vessel out of the passage's grip and towed it to port. And more recently, in 2025, the Drake Passage whipped up 40-foot waves and threw them at a Quark Expeditions cruise ship. Several passengers were injured because of the violent rolling. So yeah, the Drake Passage is still seriously dangerous. But then why do more than 10,000 ships keep going through it? Hey, I've got the same question. For adventurers, it's easy to understand. They come looking for trouble, and the passage happily provides it. Cruise ships, too, would rather skip dinner than miss a chance to visit somewhere extreme and unusual. But cargo ships pass through the Drake Passage as well. And for them, the main goal is simple: get from point A to point B. And the Drake Passage isn't the only way from the Atlantic to the Pacific, or the other way around. There's the Panama Canal, after all. So why choose the Drake Passage? It all comes down to the Panama Canal. It's safe, it's huge, but still not huge enough. If you're a medium or large ship, welcome, it's a great route. Pay the fee and go. But if you're a supertanker or a massive container ship, forget it. You'll try to squeeze through and end up stuck for good. I'm not that wide. And even if you fit, you still have to wait your turn, then move according to a strict procedure. If someone ahead of you hesitates, the whole line freezes and you can get stuck for days. That's hundreds of thousands of dollars down the drain. That's better. Wait, are you kidding me? A lot of ultra-large ships still go through Panama. They just carry way less cargo than they could. But even so, the Drake Passage stays busy. Why? Well, the Panama Canal has caused a lot of problems. What can't it exist without? It draws fresh water from reservoirs, and lately there hasn't been enough. Less water there means less water in the canal, which means it can only handle smaller ships. Or bigger ships, but not often. Here's a clear example. Usually the canal handles about 38 to 40 ships a day. But in 2023, during the worst drought, they basically had to slam the brakes. The canal was letting through only 22 to 24 ships, and it kept pulling that trick through all of 2023 and part of 2024. And you know what that meant for shipping companies? A nightmare. Plans destroyed, schedules collapsing, supply chains breaking, massive losses. Everyone running around screaming. And suddenly the Drake Passage doesn't look so bad. You can route a ship through there, but is that the only alternative? Actually, no. There's another route, and that one is where things get truly awful. Have you ever heard of the ships Erebus and Terror? They even made a TV series about that whole story. Here's the quick version. In the mid-19th century, the British launched an expedition, and every single member of the crew, 129 people, died. It's one of the biggest tragedies in the history of maritime exploration. The ships weren't found until about 170 years later, and in 1850, another vessel set out to search for the missing expedition and got trapped as well. That ship was also discovered only many years afterward. So where is this natural black hole? All of it happened right here in the Northwest Passage in Canadian waters. For a long time, sailors have eyed it as another route between the Atlantic and the Pacific and back again. But as you can tell, this option's anything but easy. Let me explain why. The first and most obvious obstacle is ice, and the ice here behaves like it has a mind of its own. At any time of year, even in summer, local flows drift around, pile up, and pin ships in place, sometimes leaving them stuck for weeks. That alone's enough to make you choose a different route. But that's only the beginning. Take a look at the map. The Northwest Passage is a maze of narrow, twisting straits. If the Drake Passage and the Panama Canal are basically straight highways, this is more like threading a needle through a canyon. One wrong move and that's it, you're grounded. Your hull is breached, it's freezing, and there's nobody around to save you. Wait, why is that? I looked it up, and it turns out there's basically nothing out there. No emergency ports, no fuel stations, no repair services, and there aren't any rescue vehicles within hundreds of miles. If you run aground, break down, or get lost, then that's it, you're on your own. And don't forget the weather, it's as hostile as it gets. The Northwest Passage doesn't like strangers. First it captures them in ice, then it beats them up with wind and blizzards, blinds them with fog, and tops it off with sudden temperature swings. Even the most seasoned sailors can get trapped, and forecasts won't necessarily save you. But if it's that dangerous, can it really be an alternative to the Panama Canal? This is where you'd expect technology to step in. Modern ships navigate by satellite, and all data updates constantly. Powerful icebreakers can chew through ridiculously thick ice. In theory, all of that should tame the Northwest Passage at least a little, but in practice, not so much. In 2023, only 42 vessels made it through, and in 2024, just 18. Not exactly the next Panama Canal, right? Because the passage remains dangerous no matter how well you prepare. I even found examples. In 2010, the cruise ship Clipper Adventure took tourists through the Northwest Passage. It was built for Arctic conditions with a reinforced hull and an experienced crew, but the passage still won. In Simpson Strait, it snagged the ship on an underwater shoal and brought it to a dead stop. People had no choice but to sit and wait until help arrived. They were lucky they got rescued. Unlike the crews of the Terror and the Erebus, 8 years later, it happened again. In 2018, the Northwest Passage ran the research vessel Academic Eye off aground with 163 people aboard. Again, they were lucky. They were rescued the very next day, but the expedition was ruined. And this was after serious preparation. Specialized ship, equipment, professional crew. Come back soon. So here's the weird part. On paper, the alternative exists, but in reality, it's almost like it doesn't. Still, you can't just pretend the Northwest Passage isn't there and keep funneling everything through Panama or around the stormy Drake Passage. So there's only one real option left. Do something about this northern trap. Look at what's happening. In summer, Arctic ice retreats. That's normal. That's just what summer does. But lately, summer has been getting longer, which means the ice has less time to trap ships. And if you look at climate models, by the middle of the 21st century, summer sea ice may stop being a major obstacle altogether. In some straits, it'll clear even earlier, and overall, it'll be thinner, weaker, and easier to break apart. No more deadly Arctic choke points. So yeah, there's at least a hint of good news. One of the most dangerous routes in the world's oceans might actually have a brighter future. You owe me a like. See you later.